Hello students, our new topic will be Mohr circle of stress. Earlier I have said that the we can find the stress condition on any particular plane in a body which is subjected to load. We can find the stress condition by two methods. One is analytical method and another one is graphical method. Analytical method we have already seen. The Mohr circle method is the graphical one. Let us see that well, at the last class uh, we have got these values that is if a body is subjected to load such as sigma x, sigma y, and shear stresses tau xy, then then for a particular section, for a particular plane which is situated at an angle of theta, uh, we can find the normal stress and shear stress on that particular plane by these two formulae, right? Now this, suppose we are taking from this equation, we are taking this part in this side, so what we will get sigma n minus sigma x plus sigma y by 2 is equals to sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta, right? Now suppose we are squaring this equation in both the sides, so what we will get this as whole square sigma n minus sigma x plus sigma y by 2 whole square, and for this section we will get this plus this whole square, and if we split this by the equation a plus b whole square, so we will get a square plus b square plus 2ab, that is 2 sigma x minus sigma y by 2 cos 2 theta and tau xy sin 2 theta, right? This is one equation, and suppose we are squaring this equation as well, so what we will get tau square and this whole square, that means a minus b whole square. If we do the equation, that will give a square plus b square minus 2ab, so that is 2 into a x sigma x minus sigma y by 2 sin 2 theta tau xy cos 2 theta, right? Now we are getting two equation, this and this equation, after of squaring the initial equations, right? So if we add these two equation, what we will get sigma n minus sigma x minus plus sigma y by 2 whole square plus tau square with adding, so this part plus this part is equals to, in this right hand side, this whole part and this whole part are same, right, and different in sign, so this will be omitted. So what we will get, sigma x minus sigma y whole square by 2 whole square cos square 2 theta and sigma x minus sigma y by 2 whole square sin square 2 theta. So if we add and take common this part, this will be sin and cos, this will be equals to 1, so we will get simply this, right? So we will get sigma x minus sigma y by 2 whole square, right, and tau xy square, right? We are getting this equation. after squaring and adding those two initial equations what we have got from the analytical method, right? So if you look closely, you will see that this equation is similar to the equation of circle, right? What is the equation of equation of circle? Equation of circle is x minus a whole square plus y minus b whole square is equals to r square. What are those? A and B, where A and B, if a circle is situated over there, A and B is the coordinate of the center of the circle. Coordinate of the center of the circle. Suppose the center is C, coordinate is A, B. That means from this to this, this is A, and this to this, the abscissa is A, and the ordinate is B. Right. So if you look closely, we can see that this is also a circle equation, right, where the p value is equals to 0, we can say, right? And the r value, the radius, r is what? R is the radius, right? R is the radius. So radius is equals to, for this circle, the radius is equals to root over this, right? So that means we can draw a circle. By this equation we can see that we can draw a circle from which the any point of perimeter will give, obviously give some coordinate x and y, right? Will give you some coordinate of this point, particular point, that is x and y. This x and y will be sigma n and tau, right? As because you can see from this equation, this is equals to sigma and this y is equals to tau. So if we draw a circle for a particular case, any point on the perimeter will give some x y, and this x y is basically nothing but sigma n and tau. That means the normal stress and shear stress for a particular plane, right? Now what is the plane? We have to find out. Now let us see how to draw the Mohr circle and how we can find out any kind of sigma n and tau for a particular plane. Let us take the example what we are doing for the last case, that is the most general case. That is, if a body, if a two-dimensional body is subjected to direct stresses in both the directions, right, sigma x and sigma y, and as well as the shear stresses in all the direction, that is tau xy and tau xy. For this case, how we can draw the circle, right? Now what will be our coordinate of the circle? Coordinate will be a and b. That means this and 0, right? So how to draw? We can take sigma in abscissa and tau in the ordinate, right? So if we do so, in this direction there will be minus sigma, and in this direction we have to take minus tau, right? Now we have to do some sign convention. Let us take the tension as positive, compression as negative, and for shear force, if the shear force is rotating the body clockwise direction, this is rotating the body clockwise direction, so we can take this as positive. And if the body if the shear stress is rotating the body in anti-clockwise direction, so we can take this as negative, right? Suppose we are taking the sign convention. So obviously, if the circle is giving you the stress condition of all the planes for this particular body, so obviously on that circle perimeter there will be 2 points which will be giving you the stress condition of this vertical section, vertical plane, and the horizontal plane. Obviously there will be 2 points, right? Let us find out those 2 points, as because we know the stress condition for vertical and the horizontal one, right? So let us find out the points, and then we can find we can draw the circle, right? To find out that one, we have to get 2 points which are having the coordinate of sigma x tau xy, as because for this vertical plane the point will be having the coordinate of sigma x tau xy, right? And for this horizontal plane, the point which will be giving you the stress condition, that point will be having the coordinate of sigma y and tau xy, right? Now uh, let us find out those 2 points. First of all, suppose we are assuming that sigma x is greater than sigma y. So let us first of all find out the point which is giving you the stress condition of horizontal section. So the coordinate will be sigma y tau xy. Suppose we are taking a point which is sigma y apart in abscissa, right? Correct. Now what will be the ordinate of this point? The ordinate will be tau xy, right? Tau xy. Now let us see what will be the sign convention. Tau xy in the horizontal plane is in this direction and in this direction. So obviously this shear force is rotating the body in anti-clockwise direction, so this will be negative. So if we get a point which is tau xy in the ordinate, so we will get a point, suppose B, which is basically having sigma y and tau xy coordinate. This point is having sigma y and suppose this is tau xy, so sigma y and tau xy coordinate, right? So this B point is nothing but this is the point which is indicating the stress condition of the horizontal section. Similarly, we can find out a point which is denoting the stress condition of the vertical section. So to do so, we can find out one point which is sigma x apart. Sigma x apart, suppose this is sigma x apart, right? And the coordinate will be tau xi. Now let us see if that will be positive or negative, as because sigma y and sigma x are tension, so we are taking in positive direction. If one of them was compression, then we have to take in the negative side, that is the minus sigma. In for tau xy in our vertical section, we can see this is the direction, this is the direction, that means this is rotating the body in clockwise direction, so this will be positive. So we have to take the same amount, tau xy amount, but in the positive direction, right? Positive direction. So this point, suppose this point is A, is having sigma x and tau xy coordinate. So basically this is the point which is indicating the stress condition for this vertical point. So obviously this point and this point will be at the on the perimeter of the circle, whichever circle we are finding out, right? So how to draw the circle? If we connect these 2 points, if we join these 2 points, obviously we can say that this will meet at a point which is basically nothing but the center. This is the 0 0, right? This is the 0 0. So if this cuts, this will cut at the center, right? And obviously CA or CB, CA or CB is nothing but the radius, right? So we have got the center, we have got the radius, we can draw a circle, right? So we have drawn a circle, right? Using this as center, this point is suppose C, This point is C. Having this as center and this as radius, we have drawn a circle. So what they're saying that this circle perimeter will give you the coordinates which are actually the stress condition for a particular plane. Just like this A is giving you the stress condition sigma x and tau xy, that is equals to sigma x tau xy, that is equal to the stress condition of this vertical section, right? And for B, sigma y tau xy minus tau xy, this is giving you the stress condition of this horizontal section, that is sigma y tau xy, right? So similarly, all the points are giving you the perimeter. Obviously, that will be all the points are on that perimeter is giving you some coordinates. Actually, those coordinates will be having some sigma value and some tau value. Those are nothing but the normal stresses and shear stresses for particular planes. Now, let us look at this thing, that is this section. If this as center, this point is a uh, the stress condition of the vertical plane. So suppose this is representing you the vertical plane, right? Now B point is the horizontal one, so obviously CV is indicating you the horizontal plane. Now what is the mutual inclination of this vertical and the horizontal plane? That is 90 degree. But in this Mohr circle, you can see the mutual angle between those two planes are 180 degree, not 90 degree. That means in Mohr circle, this angle, the mutual angle between any two points, will be twice theta. That means twice than the actual angle, right? Now suppose we are trying to find out the stress condition of this particular section. uh, if we draw the particular section, that is this, which is having a theta angle, right? Now what will be the stress condition for this particular section? We have to find out the point which is indicating the stress condition for this plane. This plane is situated as at a theta angle from the vertical section, as because we have taken sigma x as greater, so this will be our reference line. So from this reference line, where we are taking the plane which is having the theta angle from the reference line, right? So obviously in Mohr circle, this will be in 2 theta, right? As because we have already discussed that we have to take twice the theta. Okay? So this will be at twice theta in this Mohr circle. Now we have taken this angle in anti-clockwise direction. This is the reference line. So in this direction we are taking the angle. So we are taking at the anti-clockwise direction. So in Mohr circle, this is our reference line. This will be our reference line, as because this is indicating the vertical section. So from this reference line, we have to take 2 theta in anti-clockwise direction. That means in this direction we are taking suppose 2 theta, and it will cut a point, in this perimeter, right? Suppose this is x, suppose capital X. This angle you should take this angle as 2 theta. So obviously this x will be having some value of sigma and tau. So this sigma and tau will be nothing but the sigma and tau value for the particular plane, this one which is having theta, right? So in this manner we can find out the sigma n and tau value for a given section, right? That means if we draw a circle assuming suitable scale, as because we have to denote the stress in the the either millimeter or centimeter or whatever. So we have to convert these stresses, either sigma or tau, we have to convert the stress in either millimeter or centimeter, and in assuming some suitable scale, we can find out the sigma y and tau xy point, and sigma x and tau xy point, and we can cut this as center, and taking CA or CB as radius, we can find out some circle. This will give you some coordinates, sigma x, sigma and tau, right? That means this will be your sigma, sorry, this will be your tau from there to there, so this will be your tau value for the particular case, and this will be the sigma value in the abscissa, this will be the sigma value, right? So at the abscissa this will be sigma, and in ordinate this will be your tau, from there to there this will be your tau. So obviously you will get in this in millimeter or centimeter. Again you have to convert this in stress, right? Whatever the unit you are getting, MPa or whatever, so you have to convert that in stress, and you will be getting the sigma value and tau value for this thing, right? So this is the procedure how to draw the Mohr circle and how to find out the stresses for particular plane. Now another many things we can see in analytical method. Suppose this section was given to you and you have to find out the stress condition. Now again another section is given to you, that is alpha angle away, right? Now for analytical method you have to again put the value of alpha for this particular equation, this and this equation, and you have to find out the stress condition for the new section. But in case of the Mohr circle, you simply have to draw another line which is 2 alpha away, right? And you will be getting the new points, and you can, so drawing one particular circle, you will be getting all the stress condition for all the section whatever you need, right? Now what are the other things we can find out from this Mohr circle? We're getting the minimum value of sigma n and the maximum value of sigma, minimum value of sigma and maximum value of sigma, right? And you can see in this minimum value of sigma, the tau value is equals to 0, as because we are not having any kind of ordinate. In this case also the tau value is equals to 0. So those 2 points are nothing but the principal stresses, right? So this is nothing but the minor principal stress from here to here, and from here to here this is the major principal stress. So we can find out the minor and major principal stresses. Again we can find out the plane, the direction of the major and minor principal stresses, as because this will be the minor principal direction. If you take from this reference line, this will be clockwise, whatever something angle will be there, and you can take half of this and you can find out in which direction the minor principal is there. Similarly you can find out the major principal stress in this direction, you can find out the major principal stress. What are the other things we can find out? We can find out the maximum shear stress for a particular plane. So this will give you the tau max, right? This will give you the tau max value. So this point is basically, obviously this will be having some sigma value and tau value, this is the tau max value, right? So we can find out one point which is having the maximum shear stress, and what will the position of this maximum shear stress, right? So those are the things. Those are, and other thing we can find out that this major principal stress or minor principal stress are having the 90-degree angle with the this plane which is having the maximum tau value. 90-degree means in actual body this will be half of the 90-degree, that means 45-degree, right? So we can say the major principal stress and minor principal stress are mutually perpendicular, as because this is 180-degree, so this will be in actual body this will be 90-degree from each other. So major principal stress and minor principal stress in any plane, that are those are the actual major and minor principal planes. So the major principal plane and minor principal plane are having 90-degree, that means they are mutually perpendicular, and we can say that is one plane which is having the maximum shear is 45-degree apart from these two planes, right? Those are the things we can find out from this Mohr circle. Okay, so we can again take any kind of examples, we can put in the graph paper, we can draw the circle, and we can find out all the things, right? So thank you.